Good evening, ladies and gentlemen. My name is Ashley Helm, and this is my Earth Science Honors Project. My hypothesis for this project was that when making a Hubble diagram that displays star data, if there are more data points, then the graph will be more accurate. My main idea was that more data points equals more accuracy. I got my idea from the Sloan Digital Sky Survey website by adapting one of the challenges that entitled Making a Hubble Diagram and Testing the Accuracy. Most of my research was conducted on the Sloan Digital Sky Survey website, reviewing the challenge that I had chosen and taking notes on how to change the challenge to fit my needs. I also read up on the article that came before the challenge to make sure that I knew all the terminology and what I had to do to finish the experiment. In reading, I learned the definitions of such technicalities as redshift and magnitude, which are respectively distance and brightness. I also learned how to use the Sloan Digital Sky Survey data tables to my advantage and not get overwhelmed by the sheer amount of data tables that were available to me. My design was pretty straightforward because I used the design that was described in the challenge. I did, however, change a couple of the search parameters to make it more specific than what they had originally entailed. I also used the SDSS data tables to search for the points that I needed, and I created an Excel spreadsheet for each dataset. Then I used Excel's graphing capabilities to create 3 different graphs and then calculated the fit or the accuracy of each of the graphs. These are some pictures of me during my experiment. There's one of me just checking out the website, getting a feel for it, one researching, one finishing up my data tables, and a couple of me finishing looking up at my graphs, trying to figure out what made them accurate. These are the graphs that I'm looking at. And as you can see, there's no real pattern to the organization. 10 data points has a 9.6% accuracy, 100 data points has a 5.3% accuracy, and then 1,000 points has a 7.69% accuracy. My hypothesis was that the more data points that there were, the more accurate the graph would be. However, there were not enough data points to support or refute my hypothesis because my dataset that I had chosen was much too small for the size of the universe. A little set of data that I had, at most 1,000 data points, is a mere fraction of the trillions of stars that live in our universe, and therefore my small set of data was not indicative of a universal trend or lack thereof. And because of this lack of trend, I cannot explain the relationship between the two characteristics of redshift and magnitude, because there was no pattern at all. I cannot explain how they are related to each other, if they are related to each other, and if one or the other influences the other one. For a more accurate experiment, I could have used a lot more data points, perhaps starting at 1,000,000 instead of 10, because 10 stars is nothing, but 1,000,000 stars is a little bit bigger. Now, I learned from the design of this experiment, even if I didn't exactly learn from the experiment itself. I learned that not all experiments have conclusive endings, and that you must work with what you have to come up with a decent answer. Finally, my final point is that my hypothesis can be neither confirmed nor denied because my dataset was not big enough. In conclusion, I took my ideas and research from the SDSS website, modifying as needed, and my hypothesis cannot be confirmed nor denied due to the small dataset. Since the universe is large, I should have tested a much larger area. Overall, this was a good learning experience, even if I did not exactly answer my hypothesis. Thank you for listening to my presentation.